Hello, everyone. Welcome back to another episode of SNEED-CAST. I'm your host, Alexa, and today we're here with our VP of Marketing and Sales, Ken. He'll be giving us some information on the different types of date coding technology used for secondary packaging. So, Ken, if you'll kick it off, what are some of the different date coding technologies that we'll be talking about today?
Yeah, absolutely. So one step, I want to just refresh everybody's memory on. I don't know if you're listening to this episode right after our last episode, but just as a refresher, we talked about primary packaging, secondary packaging, tertiary packaging. So we've already done the episode about primary packaging, which is the ketchup bottle as the example that I use. Now we're going to talk secondary packaging, which is the box that all of the bottles of ketchup go into when it gets transported to the store or retail distribution, etc. So that's the secondary package. Typically, more often than not, it's a cardboard box. And that's what we're going to be printing on or the different types of technology we're talking about today.
Okay, and what would you say are some of the different types of technology when we're working with secondary packaging?
Right. So typically, you're going to see, in terms of direct printing, there's usually one of three technologies that you're going to see, and then we also have labeling. A lot of times, customers are putting labels on their boxes depending on the volume of information they're trying to put on there. But from a print perspective, you start with valve jet, sometimes called drop on demand. You also have thermal inkjet, which we've talked about for primary packaging. Like I said, there is some crossover between these technologies. And then you also have high resolution print systems that are either powered by a Czar or a Trident print head, depending on your supplier or depending on the actual printer OEM that is building the printer.
So, when we're talking about valve jet or drop on demand, how does it work and where did it get started?
Right. So first, valve jet is also a very basic technology. It's very low resolution. So it's going to look in a lot of ways like a CIJ code or a continuous inkjet code, but it's just going to be on a larger scale. Typically, valve jet printers, they print a 1 inch to 2 inch print image, but it's because it's very pixelated. You're printing these dots, and in order for it to actually create an image that is legible or recognizable, you need a larger scale. But essentially, depending on the print head, you sometimes have a 7 dot, you have a 16 dot. What that essentially means is the most popular, most common valve jet printer on the market to this day, top selling printer around the world for case coating and DoD printing, is the Marsh Unicorn. That printer, I think, hit the market in the late 80s, and to this day, I believe is still the top selling valve jet DoD printer on the market. The same exact printer with the same controller, no advancements in technology, but it's a machine and it's out there, and it's like a freight train. It just goes and goes and goes and goes. Anyway, I'm rambling. So it's a 7 dot print head. It's got 7 nozzles that it's ejecting. It's creating pressure inside those nozzles to eject drops whether it needs to or not. Whereas continuous inkjet, the reason it's called continuous is because that ink is continuously cycling through the system, whether it's printing or not. Because if it's not printing, it's just going through that gutter. In a valve jet system, the ink droplets are just sitting there waiting for the pressure to be created and for the opening to shoot the drops out. So the fluid is not continually moving; it is just sitting there. That's the drop on demand aspect of it. The drops don't happen until it actually gets that trigger to print that message.
Now that you mentioned that the drops just sit on that print head, when I think about that, is there an issue when it comes to like clogging or ink drying out?
Right. That is going to be one of the main kind of not combatants, whatever, the obstacles you'll run into running a valve jet printer is that occasionally you're going to have nozzles get clogged that either need to be replaced or flushed out. If you can't flush them out, then you need to replace the nozzle and work with the supplier to get that done. Or sometimes that, depending on whose machine it is, it may mean you need to replace that print head altogether. The main benefit of this machine, the reason why that Marsh Unicorn continues to be popular today, is it's a very low ink cost. Of all of the options, it's going to probably have the lowest ink cost available to a consumer. But again, it's a very low resolution print, so you're not going to get anything like barcodes, which is becoming more and more prevalent, or not necessarily prevalent, but required these days, and things of that nature. So if you're only printing text, then it's great for you. Another kind of thing to be cognizant of is, beyond the nozzles clogging, to be on the watch for, is ink spills and ink messes. It's a technology that is known for having, because that ink is just sitting there, it'll start to drip. And so I've been to countless facilities and customer sites where if they don't have a DoD printer, I can tell where they used to have one. Because there is ink stains on the floor, there's ink stains on their conveyor, and all over. So that is, and then that's to a lot of people very frustrating. So that is kind of one of the bigger negatives to this technology, is that potential for ink spills and ink messes and that kind of thing.
And then when it also comes to drop on demand, are we looking at having a technician there, or are we looking at being able to install this ourselves?
It's a good question. I think it varies. You can see at both ends of the scale. So you can get some larger DoD systems with, a 2-inch head on it and something like that. So I think it's a matter of the individual. In a lot of those instances, you're probably going to want a technician. Now, something like the Mars Unicorn is a very basic little printer. I believe that is one that the folks are able to set up and install on their own. Last time I checked, though, that Mars Unicorn has a higher list price than our Titan printer. It's I think it goes for about $1,500 to $2,000 retail.
Okay.
For a low resolution, non-networkable printer. No bias.
Tell us how you really feel, Ken.
I'm just stating facts, that's all.
So moving on to our next type of printing technology, we're talking about TIJ, which is one of our favorites here. So Ken, if you could give us some background on it, that'd be great.
I won't go as deep as I did in our first episode on primary packaging, because it's kind of, don't want to be too repetitive. But yes, it's a thermal inkjet. It's cartridge-based technology where there are no filters or pumps or anything that are creating or the flow of ink. There's no ink tanks or anything like that. Everything, the magic happens in the cartridge. The print head is inside the cartridge. So as you change your print head out, or rather, I said that backwards. As you change your cartridge out, you're putting your print head in the system. Because of that self-contained cartridge, also eliminates any kind of ink spill or mess. I've had numerous customers, some of the ones I just mentioned, that switched from DoD to TIJ, and a big part of it was they were just tired of ink spills and ink messes. So that was a huge benefit for them. But yes, it's a cartridge bubble jet technology. Creates bubbles on the inside due to heat that is then creating the pressure that ejects the ink out of the nozzle plate on the front of the cartridge.
And what would you say that TIJ is ideal for secondary packaging?
So again, that's actually where TIJ got its start in the industry, referencing our first episode, because when it first entered, we were not able to have solvent inks in those cartridges. It was only water-based inks. And so that's really all you can print on is paper materials or cardboard materials. Still, why it's great for cardboard or that type of application, another thing that TIJ really loves is a flat surface to print on. Doesn't get much flatter than a cardboard box, and typically these boxes do run on conveyors with guide rails, so it's a very simple installation to set up your printer right up against that box, get it nice and flush with the edge of the box, and print that code. And then of course, like I mentioned earlier, more and more customers need to print barcodes or some more high resolution type things. Maybe they want to put a graphic on there or their logo. With TIJ, you do have up to 600 DPI print quality, which is the same equivalent of what you get out of your desktop printer. Again, that's the origin of the technology. So with that, customers needing those newer requirements, the lower cost of the actual machine itself, and then not only that, you can, of course, the base technology is a 1/2-inch print height limitation, but now you can stitch those together, and we also have a 1-inch cartridge, so we can get up to 1-inch, 2-inch, and so we are on the verge of launching our 4-inch version as well, but they also exist in the marketplace today. So.
And moving on to a technology that some of us might not have heard of, high resolution with Czar or Trident print heads.
Yeah, so the thermal inkjet is not the only high resolution print technology in the game, so to speak. Czar and Trident technologies have been around quite a bit longer, since the early 90s, if I'm not mistaken. The two technologies are very similar. They're piezo electronic based print systems, but they can print Not as high resolution as TIJ. I believe they usually hit out around 180 to 300 DPI, but you can still print nice barcodes. You can print logos and everything else. The nice thing about these print heads compared to thermal inkjet is the print heads themselves are larger. So with thermal inkjet, if we need to create like a 2-inch print window, we either take 4 half-inch cartridges and stack them to create that, or if we go with a 1-inch cartridge, we take 2 of them and stack them with a process called stitching, which requires it to be very precise in where it prints to make sure that those two prints line up. The benefit of a ZAR or Trident print head is that the print head itself is actually larger. So you can get a 1-inch, up 2-inch, and even up to 3-inch print head where there is no stitching. Now, that's not like a cartridge-based system. The print head is separate from the ink delivery, so there are more moving components and things to consider, like a valve jet or even like a continuous inkjet. They are rather costly print head maintenance programs. If and when that print head does go down, you can either, depending on your supplier, some have print head swaps out there that they do. Otherwise, you may have to be looking at buying or refurbishing your print head or potentially buying a new print head. But in and of its the fact that they have print head swaps in and of themselves tells you that they know that this is a print head that is going to be prone to at some point needing to be replaced. And that's just the nature of that technology, of course, just not saying right or wrong, good or bad, but it is something you should be cognizant of. And if you're exploring that technology, something you should ask your vendor of in terms of how long does these print heads last? What do you do when in the case I need to replace a print head? Do you have a print head swap program? What does that cost? What is entailed? So those are good questions for you to be thinking about, and also asking potential vendors or suppliers when you're looking at that type of technology.
By chance, Ken, when we're looking at like high resolution print heads like ZAR or Trident, what price point are we looking at?
They're pretty pricey. So I don't want to. I try not to reference us too much on this podcast, but our 2-inch case coder is $1,500. That is with a stitched, TIJ technology. If you want to get a 2-inch ZAR or Trident based system, you're probably close to $10,000 on average. Now you might be able to get a little bit lower depending on who the vendor is, maybe as low as $6,000 or $7,000 if I had to guess. But you can also easily get higher. We're about to launch, as I said, a 4-inch version of our case coder that can do 2 inches on both sides of a box. If you're looking at getting 2-inch print heads from another, from a ZAR or a Trident, now you're up to maybe $20,000. If you're looking at a 3-inch or 4-inch print head, you may be at the $30,000 mark. So they're pretty costly systems, yeah.
And we've made it down to good old labeling. So what can you tell us about labeling, Ken?
So, with labeling, typically your cost of ownership is going to be higher because you don't just have an ink cost, you also have the label cost to consider. So your cost per print or your cost per box is going to be higher. Even if you were to go with a ZAR or a Trident-based system, that cost per box, your cost of ownership, should ultimately be less than a label if you're going with a print and apply system or whatnot, even with thermal inkjet as well. The biggest reason I typically see for folks opting to go with labels on their boxes, a lot of time comes down to barcodes. So certain retail distribution giants, they have specific requirements regarding barcodes, the size of the barcode for visibility in a warehouse, the scannability of the barcode. There's a barcode rating system out there that rates barcodes, and some suppliers, not suppliers, but rather distribution, they require a certain rating of barcodes that is nigh on impossible when you're printing black on brown. So print a black barcode on a brown box. Will it scan 99 times out of 100? Yes, but it's probably not going to score higher than a C because of contrast, black on brown. Whereas if you print black on white, that's going to give you that's about as big a contrast grade as you're going to get, which goes into that score. So that's why you actually see a lot of people that opt for those labels. It's not necessarily because they want to put a label on there. It's because their retail customer is requiring it and requiring them to do labels as opposed to printing on the box directly. But we have seen a lot of customers switch from labels due to the cost savings when we do a cost analysis of what are you paying per box versus, and it's usually several cents. Maybe from 2 and 3 cents, maybe to 5 and 6 cents per box to a fraction of a penny if you're printing directly on the box. Huge savings there. But that's typically, labels. A lot of times you see things with it's when there's a lot of information that needs to be placed on there. Sometimes ingredients lists, etc. But barcodes are a big part of it as well.
Well, Ken, we'd like to thank you for giving us information on valve jet, thermal inkjet, high resolution, and labeling date code technologies. We'd also like to give this opportunity if you've forgotten to mention anything, or if you just want to add any additional comments on these types of technologies.
No, I can't think of anything. I think we've kind of covered the gambit. Of course, anybody has any questions out there, or any further thoughts, I should have mentioned this in our other episode, but you can always reach out to us. We're happy to answer any questions for you. Leave some comments, and we'll follow up with you on those, or you can reach out to us on social media or even through our website, and happy to help you through the process of trying to consider what's the right technology for what you're trying to achieve.
Of course. Thank you so much for all of this information, Ken. And like always, everyone, make sure to like, comment, subscribe, and hit that notification button down below to stay up to date with all of our great content. Make sure to leave any comments if you have any topics that you'd like to see us talk about here on the show. Bye, everyone.
Have a good one.